In this video, I'll be explaining question 2 of homework 4. Uh, so we are given a random variable x which is uniform in the interval minus 1 to 1, and we need to find g of x such that if y equals to g of x, then uh, f of y is equal to e raised to power minus y times u of y, where u of y is a unit step function. So since we are given that x is uniform in the range of minus 1 to 1, so first I have plotted f of x which is uniform in the range of minus 1 to 1, and the CDF of x, which is the big F of x, it can be drawn as plotted as follows. So we can see that for value of x less than minus 1, the cumulative distribution will be 0, and for for x greater than 1, the cumulative distribution, since probability sum up to 1, it will be equal to 1. And for the values between minus 1 to 1, we'll get a straight line uh, which will be 1 plus x by 2. So this can be written as follows. So f of x is equal to 0 for x less than minus 1, 1 plus x by 2 for x between minus 1 and 1, and 1 for x greater than equal to 1. Also we are given that f of y is equal to e raised to power minus y times u of y. So to find the CDF, we will take the integral over the PDF from minus infinity to y, and since it's a unit step function, we can ignore the values from minus infinity to 0, and we'll take the integral from 0 to y, because for the other values this term will be 0. So on taking integration, we'll get the final value as 1 minus e raised to power minus y. And now to find the g of x, we can set the CDF of x is equal to CDF of y, which is basically setting 1 plus x by 2 is equal to 1 minus e raised to power minus y. So on solving this equation, we get y is equal to minus log to the base e 1 minus x by 2, and this thing will be valid only for the range of x between minus 1 to 1. For the other range of x, we'll have that is for x less than equal to minus 1, g of x will be 0, and for x greater than equal to 1, g of x will tend to infinity. So when we plot this curve, we will get it in the following form. So we can see that for x less than equal to minus 1, this is equal to 0. For x greater than equal to 1, the value of gx tends to infinity, and for x between minus 1 to 1, we get minus l log to the natural base 1 minus x by 2. When we plug in the value of x equal to minus 1, we can see that this term will be 2. So ln 2 by 2, which is equal to ln 1, will be 0, and for x equal to 0, we'll get minus ln of 1 by 2. So this will be this value. Yeah.